All right, well, welcome everyone to our session number 8 on space access. I hope everyone has had a great week so far participating in the different talks we've had. I'm sure folks have discovered this already, but in addition to all the papers and presentations that we typically push out for free, we've also got all the recordings for all the presentations, Swifties and NASA talks, also available for you to look at offline as well. So hope you've had a chance to do that today, especially for this session at hand. We're going to have a chance now to engage with each of the presentations and presenters for the space access session. And I would be normally introducing the moderator for this talk. Oh, he's joining, great. So let's get AC Charnia up. AC is with Blue Origin. He helps lead their civil sales of Blue Origin, including business development for the Blue Moon Commercial Lunar Lander Program, where he is a capture manager for their Human Landing System program with NASA. His previous experience includes roles at Virgin Galactic, that is now part of Virgin Orbit, Generation Orbit, and SpaceWorks Enterprises. He's a graduate of the Georgia Institute of Technology. AC?
Yeah, hey, thanks, Aaron. Thanks, everyone. Hopefully you can hear me. Welcome, everyone, to SmallSat 2020. I think it's an exciting week. We've had a lot of great talks, and I think a lot of folks are looking forward to this session. I'm your moderator today. We've got, looking on the agenda, at least 6 discussion talks. For those that want, these talks are on the SmallSat website, and all of our presenters have uploaded their videos. So if you go to smallsat.org and look at this session, session 8, you'll see the space access session, and all the primary talks have been uploaded. So I'd encourage everyone to go to those. So with this session, I think we'll start off with our first paper on frequent, reliable, and affordable access to spaces here by Lars Hoffman from Rocket Lab. So I don't know if Lars, if you want to kick it off.
Yeah, sure. Thanks, AC. Appreciate it. And welcome, everyone. I'm not quite sure how many, it looks like 200 or so participants now, 201, so it's climbing. That's great. We were talking a little bit earlier how interesting this year is versus previous years. I think last year was record attendance of 3,500, and this year 7,500 plus are dialing in, calling in, joining online. And so that's the silver lining here, I guess, and it's great that this many people are able to participate this year. And hopefully many of us will be able to attend in person next year and future years, which is a lot more fun to interact in person, to network, to go to as many of the functions and parties as possible during the week. So anyway, we'll get back to that next year, but for this year, this is the best we can hope for, and I think it's going to work out. So far, I've seen it working out quite well this week. So I'm in our Rocket Lab Long Beach headquarters, and I'm in a COVID-free conference room here, so all is well. And we've continued to work throughout the whole COVID period here and continue going forward. We've been building and producing engines and avionics in our factory here. Over in New Zealand, they actually went to stay at home for 5 weeks there, which disrupted us for a little bit, but we're back to launching now. And we are set to launch at least once a month here going forward for the foreseeable future. And as the market demand continues to increase, we're able to respond to that. So in the presentation that I recorded, I talk about all of that. You can watch that to get a little bit more detail. But we're more than just a launch company. We are a space company, a space technology company across the spectrum, both launch, but also now with our Photon satellite bus that can offer a custom solution for people to put their payloads on orbit. So we can take you from idea to orbit. We also provide a ground segment solution through our partnership with KSAT, the largest commercial ground segment in the world. And we offer other solutions as well. So if you have an idea, you want to get to orbit, come talk to Rocket Lab. We're happy to work with you and come up with an ideal solution for you. So I'll stop there and back to you, AC, for the rest of the introductions. Thank you.
Okay. Thanks, Lars. So I think just to remind everyone, our approach here is to allow each of our panelists to present for a few minutes, and then we'll get a Q&A after each each person presents a quick summation or summary of kind of where they are. So our next paper or presentation is the 2019 U.S. Government Orbital Debris Mitigation Standard Practices from John Bacon at NASA. So John?
Good afternoon. I go by Jack. I've been a veteran of NASA for now 30 years. I think I'm the only person on this panel that was alive before we had any space debris at all. My big project in life has been to integrate the International Space Station. And on that vehicle, I would say that there are at least 1,000 people attending this conference that are of the generation that have not known a second of their lives when we haven't had people in the cosmos. So we've gone from zero orbital debris to an environment where people have been constantly threatened by it for the entirety of your lifetime. During my career at NASA, we've seen the orbital debris environment grow by well over an order of magnitude, and that is not going to stop. 40 years ago, this last year, the Orbital Debris Program Office at NASA became the very first center in the world to be concerned about and to start establishing policies and science around the problem of orbital debris. And we now are at the tip of the spear of the US government with agencies from FAA, FCC, the DoD, join us each year as we negotiate with 13 partner space agencies around the world. This includes the Chinese, the Russians, the Indians. We work internationally to try to establish global concurrence on how to preserve the environment up there. So sadly, for those of you youngsters growing up, you're finding that space is becoming more accessible, which is a good thing for you. It is a bad thing from a sense of traffic congestion, just like adding more cars to the highway. You eventually find that you need to start regulating the traffic a little bit better. We have had some basic principles in place for going on 25 years now. These were established as a formal US standard mitigation practices for orbital debris 18 years ago. And just this last December, based on Space Policy Directive number 3, the US government adopted an upgrade to those standard practices. You will see those upgrades not only reflected in every agency's regulatory position, but you will soon see it starting to be negotiated globally with all the other partner agencies. So this will be your first look at it if you download the presentation and the paper. It will start flowing to affect you, but truly we've tried to keep this as benign as possible, that the new policies, regulations coming down make common sense. And if you read the analog on the next to last chart, you'll see that everything that we do has a very close analog to traffic on the ground. It all makes sense. We ask that you start to embrace this. Overall, the generation coming along has been just great, but we do now have formal practices that you'll start to see in the regulations. So I'm here to help. I'm from the government. Thanks.
All right, thanks, Jack. Appreciate that. And yeah, I think I'll take a kind of moderator's prerogative and start asking questions. So maybe to you, Jack, how much have the large commercial LEO constellations approached you? How much have you approached them? What is your thinking there for some of these large constellations and the engagement that you've had with them?
Yeah, first of all, these people are space pros and they know the problems, so they were proactive in engaging the Orbital Debris Program Office and the respective agencies. They've been model citizens in general. They've designed their spacecraft for minimum damage on the ground. They have discussed maneuver plans that minimize the impact to the LEO environment. Overall, it's just been a pleasure to work with them. Certainly scary because they're deploying larger fleets than we've seen before. The large constellations together will put more functioning objects in space than we have tracked debris objects at the moment. So instantly, the just tracked number of objects more than doubles. If we start to have fragmentation events, if they collide with something, if they naturally explode, then the geometric growth of the debris environment of the untracked and still dangerous objects will be very large. So they've been excellent at adopting all the best practices. It's been a pleasure to work with them. And needless to say, though, even best practices still make us a little bit nervous given the continued growth of the environment.
Okay, and just one more question before we go to the next presentation, Jack. So what are current like analytical challenges that you have in terms of orbital debris analysis? I know the Aerospace Corp has competencies there and other parts of the government. So I don't know if you want to talk a little bit about kind of the analysis piece of just everything that's going up there and how you're dealing with it.
Yeah. So the Orbital Debris Program Office picks up for the government officially where the Space Command leaves off, the stuff that they officially cannot track. Now, there will be a small fuzz area in there where, classified edge, but very quickly you get into a regime of things where you cannot establish orbital elements. And at some point, we lose the ability to actually screen and size to build the model itself to understand what the true risks are. So we employ some very powerful radars. We employ large telescopes, just trying to get statistical counts of tracks in the sky. We have size estimation models from that. But there is a gap in there between the stuff we can see from the ground and the stuff where we get return samples from space station or other spacecraft where we can count the little dings. Those get exponentially larger in number where you get a significant enough flux that you can count them. But there is a critical gap in there of stuff that we know will kill a spacecraft that we cannot get statistical counts of return samples, and we cannot see in any way from the ground. So we do a variety of chamber tests, and we're working on one now called DebrisSat, where we intentionally smash a spacecraft at hypervelocity speeds and try to count and characterize the debris that comes out, but it is still a little bit of a black art. Mm-hmm. So unfortunately, we have to be conservative in trying to estimate what that damage can be. Those new regulations reflect that conservatism.
Okay, thanks. Let's see, on to our next presentation. And once again, all these presentations, the primary ones are on the website for the Small Satellite Conference. We have the presentation entitled The STP-2 Mission Rideshare Lessons Learned from the Air Force's First Falcon Heavy Launch. And I believe we have Barbara Braun will be presenting that, right, Barbara? And
you're on mute, Barbara.
Yeah.
Okay,
right,
there we go. Sorry, I had to unmute in two different places there. So yes, can you hear me now?
Yes, we can. Go ahead, Barbara. Thanks.
Excellent. Yes, so I'm Barbara Braun. I work for the Aerospace Corporation in support of the DoD Space Test Program. And I'm in beautiful New Mexico where there's a thunderstorm rolling in. So forgive me if we get some interruptions due to the weather. But the Space Test Program's job and mission in life really is to find access to space for all of the DoD space experiments. And the DoD space experiments really just means that if you've got a space experiment that you think might have some DoD interest, you can find a DoD sponsor and come to our Space Experiments Review Board, and we will find some way to get you either onto a satellite that we launch into space or onto a rocket that we launch into space. So the STP-2 mission was just the most recent in our many rideshare missions. It was kind of unique in that it was the Falcon Heavy. We often work with smaller launch providers like Lars and others. But the Falcon Heavy, we also tend to work with a lot of the first launches, especially the DoD first launches. So this was the DoD and the Air Force's first use of the Falcon Heavy, and we were able to parlay that into space for launching 24 satellites from a multitude of different agencies, including the DoD and including universities and NASA, and even the Taiwanese Space Agency. And in the course of that, we learned an awful lot of lessons related to setting your goals, selecting and accommodating the missions, the importance of ICDs and strong and flexible working relationships. We deal with a lot of policy and how do we make sure that all these, not only do we adhere to Jack's new ODMSP, but also how do we adhere to all the different agencies' interpretations of that ODMSP, and how do we handle agencies like foreign entities that are not bound by that ODMSP. And the importance of fit checks and really the importance of working together to bring this fairly spectacular launch to fruition. And all those details can be found in our paper and in the presentation that you can download from the website to have.
All right, thanks, Barbara. Just a question or two here on the presentation. So when you, as you all are looking forward to future rideshare opportunities, both on the kind of smaller launch vehicles and medium-sized launch vehicles and the larger launch vehicles, how are you gearing up to prepare for that future in some sense? What in terms of rate or in terms of capabilities that you could provide to folks out there? So.
Well, we, like I said, we tend to go on every launch vehicle that we can, including, we are in fact the front door for DoD-sponsored payloads that want to ride on the ISS and its resupply missions. And because we have a very small budget for which to launch all of these experiments that want ride to space, we tend to take anything that we can get. So if you're a new launch provider that's looking for someone to help you find payloads, we'd like to talk to you. If you're a payload that or a satellite that's looking for launch to space, we'd like to talk to you. Because we've done a lot of these, we have come up with some strategies, you know, both in our program management structure and in sort of some of the ancillary but very important aspects of doing rideshare, including, you know, the ESPA ring was originally an STP AFRL MOG effort that we put together. The ESPA class satellite kind of came out of this desire. And as we move into the future, you know, we're looking at standardizing or coming up with standards for smaller vehicles. I know Dave is going to talk about that here in a few minutes, but also for how we can extend those to make things like couple loads analysis easier. And also, again, the policy sort of roadmap and the policy and all the interactions for what do you do if you've got a commercial satellite launching on a US government provided launch? Whose policy wickets do you follow? What if you have a university that happens to be a service academy? All of these things are kind of incidental from the what we think of as the main engineering of putting a rideshare mission together, but are really important for enabling rideshare in the future. And, you know, we participate in a lot of working groups that try to figure out how we can make, you know, identify opportunities for launch, match those with available satellites, do late swap outs in the manifest for satellites that may not make it, and, you know, overall make the whole access to space question easier for all sorts of missions.
Okay, thanks, Barbara. I wanted to remind everyone we have, if you go to your Zoom chat box, we've got a Q&A tab on the bottom. We are collecting questions and we'll ask them as we rotate through some of the panelists. So please continue to submit those Q&A questions and we'll try to get those answered as we go through the panel today. So thanks. Going on to the next presentation, once again available on the SmallSat website for this year's conference, is leveraging the success of the CubeSat standard to create a SmallSat standard for the ESPA spacecraft. And I believe we have Dave on the line who's going to be presenting from Cal Poly. Dave?
Yeah, hi. Thank you. So my name is Dave Pignatelli. I'm research staff at Cal Poly, and I'm here to talk about a standard that we are trying to work on at Cal Poly to essentially streamline the launch process for small satellite missions. Essentially, we've seen that the space industry has found such a huge use for these smaller satellites that are can be rapidly launched and developed. However, when you get to start aggregating these spacecrafts onto larger launch vehicles, you have all these different shaped pieces of the puzzle, and they all have to come together. And it basically turns into a series of very specific problems that are solved in succession. So as we've seen from the CubeSat design specification, a standardized form factor is really beneficial for rapid launch manifesting and development for both spacecraft and launch vehicles. And it also makes the integrator's life a little bit easier. So essentially we're looking at some of the primary factors that make all these different spacecrafts difficult to integrate together, especially, you know, mass, dynamics, electrical interfaces, and separation systems, and essentially trying to narrow the application of these systems so that we can be a little bit more efficient in our analysis and integration efforts. So, Yeah, we've taken a stab at, we've been talking with several different sides of the industry, including spacecraft developers, launch vehicle developers, and integrators. And we've been looking at a way where we can essentially streamline this process without curtailing any innovation and making it too hard for new science to be implemented. Mm-hmm. And yeah, and there's a lot more detail in both the paper and the presentation.
Okay. Thanks, Dave. A kind of a question as we're looking at kind of small sat standards to kind of accelerate all of what's happening in the industry. What's your thinking in terms of reference environments and loads and how to think about that? You know, as developers, you could look at a suite of launch vehicles and try to be very accommodating. You could look at government standards that are promulgated out there. You know, what's your thinking there in terms of what are the reference environments, loads that we should be kind of standardizing to, maybe?
Yeah, so the initial effort has been looking at the available launch environments that are out there today and saying, you know, hey, if you're a small satellite and you design to an enveloping, you know, random vibration environment, for example, that will cover all the launch vehicles, then you'll pretty much ensure that you're good and you'll be prepared for the launch environment that you're actually going to get. The thought is that by the time you're ready to actually go forth and do the testing, you're probably going to have your mission specific environments, so you don't actually have to over test your spacecraft, but essentially defining that initial envelope with you know, the entire, you know, that basically covers the different high areas, you know, across the frequency range, for example. Then if you design to that, then you should be more than adequate for whatever launch you ended up being manifested on.
Okay, thanks. And since we're on you, Dave, we've got a question coming in that I can ask you. What are the biggest hurdles to creating an ESPA class standard?
Oh, well, I guess the biggest hurdles are that we have all these, you know, once you get above CubeSats, you're no longer a containerized spacecraft. So trying to impose, you know, a specific volume, a specific mass, and everything that can be very difficult. So I think the biggest real hurdle is trying to basically let everybody play in this standardized pond, if you will. So we're including, you know, what people want to do without, you know, causing undue engineering efforts down the road when we go to launch. So I guess the biggest challenge is going to be making sure that, you know, we're not curtailing the innovation. We're letting people develop what they want to develop, but we're still able to effectively minimize the non-recurring engineering that goes in on the launch vehicle side, on the integrator side, and even on the spacecraft developer side when they talk about how they're interfacing with the launch vehicle.
Okay. And if anyone else, I think on the panel, if you want to answer that question as well, or take a stab at it in terms of the biggest hurdles you see to creating an ESPA class standard. Don't know if anyone else on the panel has any thoughts on that.
Yeah, I do think, you know, I agree completely. It's, you know, you have to make the standard open enough that lots of people can play and that you don't stifle innovation, but restrictive enough that you can solve the problem of what I think of one of the bigger hurdles is, again, it's not containerized. The bigger mass of ESPA class means that unlike CubeSats, they do tend to participate in the couple loads process, and then the vibration and launch environment standards are kind of very different for both very different launch vehicles and then very different launch configurations. You know, whether you're in the load path, whether you're hanging off the side of a ring, and so forth. It's very hard to find a standard that envelops everything that isn't unexecutable. So trying to handle the couple loads problem, handle the environment, the launch environment problem, and still make a standard that's achievable by small satellites. I think that's the tough part. But I'm very happy to see that we are working that, because I think that's the key to getting us to essentially, you know, you buy a ticket on a ride and can change rides if you need to, can adjust to give us the launch flexibility that we need.
Okay. Thanks, Barbara. Let's see, anyone else before we go on to the next presentation? Okay. Yeah, once again, thanks for the questions. And once we finish the final introductory remarks, we'll go back to some of the questions that you've been putting out there. So thanks once again. Let's see, the next presentation on the agenda that I believe is also on the website was VV16, the first Vega rideshare mission flight. And let me ask if we have our presenter on the line from Avio. I do not believe we do. Just checking one more time. Going once, going twice. All right. Please check out their presentation on the website. They did spend time to upload it and develop it. So I'd encourage you to take a look at that. Once again, the title of that presentation was VV16, the first Vega rideshare mission flight from Avio. All right. Concluding the introductory remarks for our panelists is our folks from Virgin Orbit and Vox Space. The title of their presentation is Building a Global Launch Network, Extending the Reach of Dedicated Small Satellite Launch Using New Data-Driven Spaceport Assessment Tools. And I believe presenting on behalf of Virgin Orbit and Vox Space will be John Fuller. So John?
Yeah. Hey, AC. Good to see you.
Good to see you.
Yeah, everyone. Thanks for having me. My name is John Fuller. I'm the Director of Advanced Concepts at Virgin Orbit. Just like to send a shout out and thank you to you, Aaron and Michelle, and also Marianne for organizing a very nice conference and pretty extenuating circumstances. I think everything's gone off pretty much without a hitch. So thank you again. I'm here to present our paper and a presentation on Virgin Orbit's recent activities in developing a global spaceport network. Before I do, just for anybody who isn't too familiar with Virgin Orbit, we're working to develop a small liquid cryogenic rocket that releases payloads into space, about 300 to 500 kilograms, using a carrier aircraft and baseable anywhere around the world using transportable assets. This is actually a picture of it right here behind me. We usually launch it in the other direction so you can read the whoosh, but fix that later. So I'm in a conference room here, just literally across the street from Lars. It's we're really socially distanced. But anyway, so recently Virgin Orbit's been doing a lot to talk about what basing this system around the world can really offer, and what kind of flexible and responsive launch options you get when you have a modular system with an aircraft that can be replicated, with ground support assets that can be replicated, and sort of what that offers our payload customers as well as stakeholders around the world. But up until now, what's sort of been missing from that is a real quantitative definition of that. And that's mainly just because of how difficult it is to really communicate the sheer amount of access you get from such a system. So a couple of years ago, we took it upon ourselves to create a set of tools that really definitively do this. And we're really happy to debut these tools at this conference. Since SmallSat is in its heart a technical conference, we wanted to use this to really release this. So if you haven't seen our paper yet, it's online. It's fairly beefy, and of course it still doesn't have all the terabytes of data inside of it that you could see. So if there are any questions you have, feel free to reach out to me afterward. But really what it gets into is we've created a tool that will go and simulate the thousands and thousands of potential release sites around any given spaceport around the world. We've done this for our announced set of spaceports, which are the Mojave Air and Spaceport here in the US, Florida and Guam out in the Pacific, Cornwall Airport in the UK, as well as Spaceport Japan, which has recently been announced to operate out of an Oita airport in the mainland Japanese island. So we take this tool and we simulate these thousands of trajectories and submit them to the same regulatory rigor that we would do for an FAA approval process. And then we find out what the E sub C and also the telemetry coverage and other aspects would be when subjecting that same trajectory or those tens of thousands of trajectories to fly over those downrange populations. And what it does is it gives you a very stark color map and other data that you can act upon that says, this is where I would want to operate this air launch mission, and this is where I need to send my aircraft. Maybe I want to have 2 or 3 possible release sites in the vicinity of a spaceport, or maybe I would like to have several spaceports as candidates. for one particular mission until I down select later. So having this process and having this tool set in place allows us to rapidly analyze these kind of missions right up front, well in advance of what a customer even knows what they may need, so that we know exactly where it might be best to operate this mission, and to also reduce costs, increase efficiencies, and streamline everything using our very high pre-production line. So naturally, it's very difficult to talk about everything that's in the paper. I invite everybody to watch the presentation online, and also download the paper if you like, and reach out to us, surely. But I really welcome any questions that come along. And again, thanks for having me here today.
All right, thanks, John. A quick question before we kind of go to the whole stream of questions we've been getting in. So John, looking forward, what kind of additional analyses are you thinking you might be working on or would like to get more involved in terms of extending the capability you've just shown us?
Well, that's a loaded question. Naturally, in my group, we operate on anything that's not the baseline Launcher One vehicle. So that can be increased capabilities, increased flexibility of the baseline system, other ways of using Launcher One for alternative purposes, and also third stage kind of concepts, as we announced with our Virgin VIP service. That's a service where we'll be launching a satellite to Mars with a consortium based in Poland. So really, it's a huge gambit, and we could get into lots of detailed discussions on any of them. Of course, only the ones that are publicly announced so far. But suffice to say, there's a lot you can do with air launch, and we have our finger on the dial of just about everything you can do with it.
Okay, thanks, John. So now I thank all the presenters who gave a quick overview of their talks. Once again, on the SmallSat website. We've got several questions that have come in, and I'd like to move around in terms of some of our panelists and provide them an opportunity to answer some of these questions. We've had some questions come in specifically for specific presenters, and so I'd like to start off with Lars. So we've got a few questions that have come in, Lars, that and I think it shows the level of interest in the community for an announcement you just made this week, which is the updated payload capability for the Electron. And there are questions regarding that capability, I think reflective of interest in the community. And so the question, just taking one or two questions and combining them for you on the upgrade that you announced, is that a business decision or is that a spinoff from recent battery updates, was one question. And I think associated question with that someone else had was, how generally did you achieve that? And beyond this upgrade, are there any additional upgrades planned? So basically a series of questions, I think, on the announcement, Lars, this week that you made, and if you want to answer that.
Sure. Yeah. Thanks, AC. And I'm glad to see people are reading our releases. This is a very exciting announcement for us. So really, this has been evolutionary. We are a company that is continuously innovating on everything we do, from the materials, designs, manufacturing, logistics, you name it, launch ops. And so we're always looking to how we can do and make things better to get more performance, to save on costs, to improve our schedules, all of these things, improve reliability, all of these things. And so this is a byproduct of that. And really, the focus in the announcement is on the improved battery performance. The batteries are a primary element of our design. As part of our proprietary design, where we have batteries that are driving electric pumps, which allows us to have a very small, compact, very efficient design for our engines, our Rutherford engines. But the batteries are heavy, and so we've been trying to get more energy out of our batteries, greater energy density, greater efficiency from our batteries, and that's what we've been able to eke out to improve our performance. But throughout the vehicle, we're improving here and there, where we save a few mass, a little bit of mass here, a little bit of mass there, and overall that's allowed us to improve our performance. So what we announced today was our performance to 500 kilometer SSO as a design point is increased from 150 kilograms to 200 kilograms, and we're able to deliver up to 300 kilograms to lower inclinations and lower altitudes. So that's opened up our performance envelope quite a bit. And you asked, or one of the questions was about other upgrades. And the other thing I'd like to point out is on our website, besides the public announcement that we released today, we've posted an update to our payload users guide, and you can go in there and see this performance and the performance curves that are associated with that. But the other thing that I'd like to point out in there is an expanded fairing that we're offering as well. A lot of our customers are asking for a little bit greater volume where mass isn't really the limiting factor for that particular mission. And so we've offered an expanded fairing that's going from 1.2 meters in diameter to 1.8 meters in diameter. That's quite an increase. We also are able to customize for any mission if we need to do a variation of that. In fact, one of our missions coming up soon will announce needed some adjustments to the current fairing to be able to accommodate their payload. So we're a company that's able to do that kind of custom build, custom design for any of our customers. So the increased mass to orbit performance and increased volume from our larger fairing are two things that we're really excited to announce in this public release. And we'll have other announcements coming out this week related to our recovery program, which is progressing quite nicely as well. But I'll stop there and allow for other questions. Thank you.
All right, thanks, Lars. Lars, an exciting time, and thanks for the update. The next question I will give to all of our panelists, and just anyone who's interested, please answer. So the question that we have is, do you see launch becoming a commodity in the standards above the CubeSat standard? You know, an ESPA class standard. And what's, I think, similarly to previous questions, what is the biggest hurdle to creating this new standard? So it's essentially, you know, what's launch is the commodity above CubeSats and the hurdles to creating some of that standard once again. So I don't know if any of our panelists want to take that.
I can start with that one.
Go ahead, John.
Yeah, so as an organization that's looking to bring launch to be more like an airline process than anything else, I can say we definitely believe in launch becoming more of a commodity. The paper we've talked about today, and also all of our talking points over the past couple of years in terms of the flexibility and reach of air launch, means that we really believe that you can get this to a point where you can operate missions within days or less, and that's launching multiple missions in terms of campaigns and having more and more aircraft based around the world. So we're firm believers in that. I think just right now, maybe the main obstacle from our point of view would be bringing costs down across the industry such that more spacecraft, more rockets are produced at a higher rate. And as that demand increases, and as we are able to field more and more missions and move our system around in that way, I think those costs will come down, and we'll start to see launch becoming more of an airline-like process.
Okay, thanks, John. Any other comments from any of our panelists on that question about standards and commoditization of launch?
Yeah, I'd agree with John. That's what we're attempting to do too. Really, launch is just the first element. Getting to space is a high barrier, and trying to make that reliable and affordable and available. That's our mantra. That's what we're going for, and that's what we're delivering. But there's much more to this. You know, once you get to orbit, being able to precisely insert into the orbit of your choice, being able to maneuver on orbit, those are areas that we're expanding with the Photon sat bus and spacecraft. And so, you know, it really is about opening up that access to space, and that allows more people to get onto orbit and into orbit and be able to operate on orbit. Really open up the ecosystem, whether it's in LEO and other Earth orbits, or maybe even beyond, cislunar and beyond. So yeah, I agree with you. That's definitely the path that we're on, and the path we need to continue following.
Okay, thanks,
yeah,
Lars.
I did want to. Sorry, I wanted to also jump in and say that, yeah, I obviously agree. I hope that we move in that direction. I think that what we're going to need in terms of addressing the question of obstacles, we talked about some earlier, but the overarching obstacle, I think, is the appetite for compromise. You know, this is the difference between flying on an airline and flying on a private jet, right? I would love to be able to fly on a private jet where I could go where I wanted, when I wanted, at the exact time I wanted, without all these other people around me. But if I can't afford right now to either launch a satellite on a dedicated rocket or fly on a private jet, So ultimately, I have to be able to go to, perhaps a slightly different orbit than I'd like to be able to go to, or I'll have to redesign my spacecraft to be a little more, a little more robust to a variety of different environments. And all of that, I think we will get to, but it takes a bit of, a bit of work to get from this view of space as something exquisite to something that's commonplace. And that requires some compromise in order to get there.
I'd like to just add one quick point to that as we standardize and we start to get scores of nearly identical satellites coming out of a single launch, it underscores the need for the satellite owner operators to please coordinate with the 18th Space Wing. At last year's small sat, I was aware of a half a dozen satellites that said, oh yeah, we were cataloged as object AL by the Space Command, but we know which one we were. They never told the Space Command. And so it is important when you are part of a large fleet deployment, especially as we start to standardize the format of the satellites, that they very certainly know which one is which, so that they know who to notify if there's anything to be done, for instance, in drag manipulation to get out of the way of a potential collision. So while we're busy standardizing, it underscores the need to please coordinate with the space traffic management people, because they can't tell who's who out there.
Mm-hmm. Okay. Let's see, another question, or Dave, I don't know if you want to add to that. Any comments on that?
Yeah, I mean, I think it's been pretty well covered. I mean, we keep talking about airlines, but obviously, if somebody drops out of a flight, anybody can purchase that ticket and just, sit right in without too much, overhead effort or anything. So I think that comes back to the standardization to help launch become a commodity and more like that the airline process.
Okay. Thanks, Dave. Barbara, a question for you. Does STP fly experiments to validate different spacecraft technologies? And the question here was specifically on propellant management devices for propellant tanks.
Yes, we fly. That's in fact our primary purpose, and we operate pretty much on the research and development side. So new technologies, we've flown everything from new rollout solar arrays to new imaging devices to new magnetometers to even new propellants. And, the only requirement is that you have a DoD interest, and the DoD is interested in a lot of things. Like I said, you don't have to have money from the DoD, you don't have to have sponsorship. I'm sorry, you don't have to have much more than a letter of sponsorship and to be able to convince the board that you have some military utility and that you have a good experiment. So, and even if you don't get ranked very highly, we work everything that's on our list to get you to space. So pretty much the answer is yes, we do new technologies across the board, and propellant management, especially if we get into new policy arenas where new propellants are going to be required, or where space debris forces us into the ability to maneuver out of the way. All of those things are going to be of high interest to not only the DoD, but the space enterprise in general.
Thanks, Barbara. Let's see, Jack, a question to you. I think one of the questioners wanted more specifics on efforts underway to work with other countries on space traffic standards. And specifically a follow-up to that is, based upon that, how concerning is it that countries develop systems specifically in the area of, let's say, testing anti-satellite weapons or in that arena?
Well, first of all, anti-satellite tests are greatly frowned upon on the international community. We do coordinate through a group called the Interagency Debris Coordination Committee. It meets annually and has several technical sub-meetings every year as well. As I said, basically everybody in the spacefaring business is part of that committee. There is a fine line between space operations and space design. So space traffic management is not really part of that organization. The principle of the 25-year rule to get out of the sky as quickly as possible, reliability standards for not self-exploding, and just probabilities of collision in your orbit design. Those are the domain of the Interagency Debris Coordination committee. There are other groups that worry more about space traffic management and you know, the bigger principles of non-militarization of space. That is not part of what we do in the orbital debris domain.
Mm-hmm. Okay. One more follow-up for you before I move on. I think this is a good question. What are some ways for undergraduate students to get involved in orbital debris mitigation?
Oh, okay. Well, reliability is certainly one of the key things that we really would prefer that the satellite not self-immolate. Colliding with another object is one thing, but we have a surprising number of spacecraft that rapidly disassemble on an unscheduled basis, and we don't have any reason to believe that it was caused by a hit of any kind. So typically, you know, batteries will blow up, propellant systems will leak. If you have a monopropellant, hydrazine, if it gets to 430 Celsius, will detonate. And so, you know, strange things happen. You just have to be vigilant about the stored energy. You know, a hazard exists whenever you have the potential to move energy through anything of value to you. And unfortunately, spacecraft are moving at, you know, Mach 25, and they tend to get intense solar heat and a bunch of things that can you know, affect your stored energy systems. And so just general reliability, design, thermal protection, and finally, we get to the safety of reentry, and we're starting to find a variety of materials that make it all the way down like meteorites. And there's a growing list of things that we prefer to do some material science to see if we can find some alternatives to those. And you can contact us at the Orbital Debris Program Office, so we can tell you what some of those materials are.
All right, thanks. Next question for John Fuller from Virgin Orbit. What extra loads do you have to design what extra loads do spacecraft have to design for in order to survive being dropped from below an airplane?
That's actually a great question. It's pretty timely as well, because as part of our launch demonstration earlier last May, we were able to cap off and validate quite a few of our spacecraft loads models. And that led to the release of a new payload users guide earlier this week, just in time for the conference. So we have been able to verify that all of our loads are underneath NASA GEVs. And so really you'll see loads that are a little bit higher in environments that are a little bit more increased over, say, a ground launch, a smooth ride, but still very well within designable capabilities for any small satellite. So just take a look at our payload users guide. You could find it on the website, virginorbit.com. And of course, send us any questions if the payload users guide isn't specific enough.
Thanks, John. And let's see, Lars, let's see, I think there's you know, this is a softball in some sense, but whenever they start a question, what are you most excited about? You know, it's going to be a good question. So what are you most excited about with your first launch from Wallops, the Mid-Atlantic Regional Spaceport?
Well, there's a lot of things to be excited about with that launch. It's coming up very soon. It's going to be a launch for the Air Force Space Test Program, actually. The mission is called Monolith. It's a critical payload that we need to get up on orbit to support operations. And so we're very excited about that. We're excited about launching from a NASA flight facility, the Wallops NASA flight facility that's under oversight of Goddard Space Flight Center. So a lot of interactions there, launched from US soil, and a launch from a pad that we built in less than a year. We started building that in February of 19, opened it in December of 19, and I was down there on March 13th, Friday the 13th, as part of the Satellite 2020 conference. I was in DC, drove down to Wallops, about 3 hours away, to watch us roll out the Electron launch vehicle to the pad, bring it vertical, and even light the igniters to do an end-to-end test on March 13th, and then caught my flight home before we got locked down from COVID concerns. But we've been able to work throughout all of this period to be ready for launch, and we're excited for that to be coming up here very soon. So yeah, there's a lot of things to be excited about. The nice thing is it's close by to the National Capital Region for folks to come out and watch the launch. I think it's going to be very early in the morning, so it may be tough for some people, but we'll run it on the webcast, and we'll also have that available later on if people want to watch it later on. So a lot of things to be excited about. The other thing to be excited about beyond that launch is next spring, we're launching the NASA Capstone mission from Wallops as well, and that will deliver a small satellite to lunar orbit. And we're very excited about that as well, as you can imagine. So yeah, great question, and I appreciate the question, and a lot to share with everyone. So thank you.
Okay, and we have two more questions. The second to last question is really for any of the panelists that want to answer. And this is kind of something I think we all in the community have been wrestling with, trying to understand. And that's kind of in terms of the demand for new and small medium launch. Our customers, is that demand and the customer interest being driven by more control on schedule or destination orbit or something else or some combination? And I'd be curious, I think, from the launch providers and others, kind of what your thinking is in terms of what customers or the market wants in terms of schedule, orbit, flexibility, capability, et cetera. So anyone who on the panel who wants to answer that question?
Yeah, I can start off that one.
Okay, John.
Yeah, so as our focus is small dedicated launch, as many small vehicles are coming out with, I think we really focus on our bread and butter as being access and what orbit really the customers want to see. Schedule is of course important, and it comes up right after that. But I think as we reach the cadence that we're looking for with that commoditization we were just talking about, it's going to take a backseat to the specific orbit that these customers want, because obviously there is the rideshare opportunity, and you can go on a big rocket that will take you to one place, and then you need to work with that. But then there are a lot of people who just can't go to that one drop off or those two drop offs that those rockets go to. So that's why we've worked hard to really establish what the possibilities are and what inclinations you can really reach with a system like Launcher One and with dedicated small launch. So that means you can go equatorial orbit, you can go 15, 20 degrees, you can go sun synchronous, or maybe some odd elliptical orbit that only matches some constellation architecture you're looking for. So while I can't speak to how many people demand other things besides their specific orbit like that, I think that's the market we focus on most, and we see as very promising, which is why we came out with this paper today.
Okay.
Yeah.
Others on the panel, go ahead, Lars.
Yeah, I'll just add to that. It's all of the above, AC, and so what we're finding is customers do have very specific requirements. By having a small launch vehicle, we're able to give those custom rides, dedicated launch, or even rideshare for CubeSats. But we're able to give precise timing, instantaneous launch timing, get you within 1.5 kilometers for your orbit insertion, on both the apogee and perigee, to get you to exact inclination within three decimal places. So there are people who have those kind of precise requirements. And going to comments that Jack was making earlier, by being able to deliver these small satellites to that precision, the customers are able to pick up their satellites and track those satellites and communicate with them immediately. So it's a matter of availability, launching when you want to launch, exactly where you want to launch. That a lot of the market is really excited about, and that's what we're providing. That's what Virgin's providing. Some of the other small launch providers that are trying to get into the market here are providing as an additional option to what they've had in the past as a rideshare customer.
Okay.
Yeah,
thanks,
and
Lars.
I also wanted to jump in and say, as a customer of both John and Lars' organizations here, all of these things are true, but also as a representative of the agency that's done large scale ride shares of lots and lots of missions, every time you basically, it's not multiple, it's like exponentially more difficult the more satellites that you put together on a large rocket. So being able to, even if you need to compromise or you don't necessarily need a precise orbit or a precise timeline, if you can limit it to 2 or 3 CubeSats rather than 24 satellites or 64 satellites, it becomes a lot easier to manage the delivery dates, the interfaces, the aggregation of all those different customers. And so I think that's and also a flexibility that small launch offers us.
Okay, thanks, Barbara. As we're running up until the end of the session, one last question, and I'd ask everyone to verbally tweet this. So limit your answer to 1 or 2 sentences. So I look forward to seeing all of you next year. And over the next 2 years, what are you most looking forward to and most focused on in 2021 and 22 in terms of each of your organizations? So one or two sentences apiece, maybe starting with Dave, and then Jack, Barbara, John, and then Lars. Right.
Well, I guess I'm looking forward to getting this small set standard out into the public and seeing if we can get it fully adopted universally.
All right. Thanks, Dave. Jack?
Yeah, I'm just looking forward to continued good governance and good citizenship out there. The large constellations are leading the way, and I think there's a lot to learn from them on how to do it right to make a reliable, large deployment and operate as a good citizen. So we're seeing good signs. Looking forward to more.
Thanks. Barbara?
Yeah, well, like Dave, I'm also very interested in seeing this standard get out there so that we can start getting more flexible in our manifesting. But I'm also looking forward to a whole bunch of upcoming STP launches with small launch providers like Vox and like Rocket Lab and others. We got a number of them scheduled for the next few years.
All right. And John?
I would just say more American rocket launches going off on a daily or weekly basis, but adhering to the same standards that Jack is looking for all of us to adhere to. I'm really excited about this industry, and I think I came into it at the exact right time, so I can't wait to see some of the smoke and fire over the next years.
All right. And then Lars?
Yep, we're looking forward to increasing launch numbers and frequency, 12, 18, 24, 36 launches a year from multiple different launch pads. We're opening up a second pad in New Zealand, so we can do 130 launches a year. So there's plenty of capacity there. We're going to be recovering boosters and reusing boosters in the next 2 years. So that's going to open up some new opportunities. And our Photon satellite or spacecraft will be able to deliver payloads beyond Earth orbits to the Moon, Mars, or even to Venus. So we're excited about all of that in the next 1 to 2 years.
Thanks, Lars, and thanks everyone. And I hand it over back to Aaron.
Yes, thank you, AC, for moderating a great session. Thank you to all of our authors and presenters. Appreciate your time and your feedback and insights. And again, thanks to the audience for participating. Wish you well the rest of this week. A few more sessions to go. And with that, see you later.